Hello everyone, welcome back to the channel. So previously we have created videos for how to create a build system like linker file, startup file, and how to create ELF file, how to create a CMake file, all those videos. So this will be common for all projects. So if you are working for any projects, you have to understand all these concepts. In this video, we are going to interface a push button. So for that, we have to configure PA5 pin as a GPIO output and PC13 as the GPIO input. So the expectation is by default LED should be turned off, and when I press push button, the LED should get turned on. So we are going to implement based on this requirement. So I will go through the schematic once. So here you can see there is a push button. It is already connected into my board. So it is by default it is connected with the pull up. So the positive supply will be directly connected to PC13. In case if the user is not pressed the push button, it will be high always. When user pressed the push button, it will be grounded. So the final value of PC13 will be 0, which is low. So that is the meaning of pull up register. Also, I will show the output pin PA5, which is LED. So it is internally connected. In PCB board itself, this LED is connected. So here you can see PC5, which is directly connected to LED. So whenever I will make it PF5I, the LED will get turned on. So this is the requirement. Okay. Now we will write the code. First I will configure the reset clock control base address, which is 400238000. I will go to the reference manual. So here you can see the base address. I'm using the base address and I will put it in macro. Then I will use this base address and I will add the offset of 30 to get the address of RCC AHB1 ENR register. This register will be used to enable the clock for peripherals. So I'm going to use GPIO C and GPIO A. So here I have added offset of 30, which is X value. So and I stored it in macro. Okay, the next step is we have to add all the GPIO configuration macros. So I copy pasted here. So here GPIO A base. Let's come to manual. And here you can see the base address of GPIO A. So I have used this and I have stored it in a macro of GPIO A base address, which is 400200000. Same way I have to do for GPIO C, and the base address is different for this C port. So the only difference is the base address of GPIO A and the GPIO C. Okay, now we will go through each register and its purpose one by one. So the first one is GPIO A mode register. This mode register we will see it in manual first. So here mode register, I will go a little bit upper. Yeah, here. So using this mode register, you can able to select the function of the IO pin. So here either you can select output pin or input pin or alternate functions or analog pin. The purpose of mode register is the function selection. And the second one, which is output type register. By default, we will use output push pull register so that it can enable both high and low in the same pin. If you are using output open drain, we cannot able to trigger high and low. So that is the purpose of vote type register. The third register is speed, output speed register. So here we can select the speed low, medium, high. And next one is PUPDR, pull up, pull down register. So you can configure pull up or pull down or no pull up or pull down. So you can configure those configurations using this register. Okay, we will see it in the schematic ones. PC13. So here you can see PC13 is directly connected to positive. This is called a pull up. When you press the button, it will be connected to ground and it will become a 0. That is the meaning of pull up register. By default it has to go positive. That is the pull up, otherwise it will be floating. Okay, the next register is IDR register, input data register. Using this we can able to collect the input of any input register. So I can go down here. Sorry, I have to go up. Yeah, here using this register you can able to collect the input of your particular pin. And ODR register, output data register. Using this we can able to read and write of the output data register. For example, we are going to use PA5, so you can able to write using this register. Okay, the same way whatever we have discussed for GPIO, it will be applicable for GPIO-C as well. Based on your alternate functions and your base address, your logic will get changed. Okay, this is the address configurations. Now we will define the configuration of our requirement. So the first thing is we have to enable the clock for GPIO-A and GPIO-C. So the 0th bit is for GPIO-A and the second bit is GPIO-C. I will go to the memory address. Here you can see the 30th offset address, and you can see the 0th bit is GPIO-A and the second bit is GPIO-C. If you are enabling this, the clock will get enabled for port A and port C. This is the first step. The second step is we have to configure the output pin of PA5. Here we are using a mode register to clear the bit 10 and 11. Then we are setting it as a output in bit 10 and 11. So here you can see this will be configured as a output mode, which is configured in bit 10 and 11. And the next step is we are configuring the output type register. So here we are configuring output push and pull so that we can able to select a high and low. Using NOR and AND operation, we are making it to 0. Okay, the next register is output speed register. So here we can able to select the speed of the output pin change. For example, low to high, high to low, the changeover will be taking some time. Based on this configuration, the speed will get optimized here. Okay, the next register is pull up and pull down register configuration. So here we are making it as no pull up, no pull down. Since this is output, so we no need to consider about this. Just I'm selecting here. So this is the major configuration of PA5 output pin. Then we have to configure the input pin, which is PC13. First we have to clear the port C mode configuration register of PC13. So I'm using AND operation and I'm clearing it. Since here you can see 00 is the configuration of input. So if I clear, it will be considered as a input. So I am clearing mode configuration. Then I am clearing a pull up and pull down register configuration. So I will scroll down here. Here I'm using AND operation. I'm clearing first. Then I'm using OR operation and I am configured as a pull up. So by default it will be 1. Okay, now I will paste the remaining part of the code. So first I will read the port C input data register and I'm comparing with one left shift of 13, meaning IDR register I'm comparing 13th bit whether it is 1 or not. If it is 1, it won't execute if condition, it will jump to else part. And in else part we are using a ODR register and we are using and NOR operation. So it will clear the ODR registers. So which is the fifth bit, which is PA5. So the first time it will be 0, and the next time it is coming, the user, for example, I will show it in schematic. The user pressed this button, so the ground is connected to positive. So now your input will be 0. So 0 and with 1 is equal to 0. So now it will execute if part and it will set the pin. So when user press this button, it will execute if condition. When user is not pressed, it will execute the else part. That is how this while loop logic will work. Now we have written our code. Now we will build our software. Now our code is compiled. Now we can flash our software. So I will connect my hardware. Yeah, now I have connected. Now I will run the command called make flash. So I will enter this. Then my software is flashed. Then I will press my user input button. You can see now. When I press, the LED is glowing. When I press, LED is glowing. Yeah. Thanks for watching the video and do subscribe for more videos.